In the world of mathematics, shapes hold a special place. We encounter them daily, from the books we read to the buildings we inhabit. Two fundamental concepts associated with shapes are surface area and volume. Understanding these concepts is crucial, not just for acing exams, but also for comprehending the world around us. Surface area, in simple terms, refers to the total area covered by the outer surface of a three-dimensional object. Imagine wrapping a gift. The amount of wrapping paper needed represents the object's surface area. On the other hand, volume signifies the amount of space a three-dimensional object occupies. Think of filling a container with water. The amount of water it holds represents its volume. These concepts are intertwined yet distinct. Surface area deals with the exterior of an object, while volume focuses on its interior. Mastering these concepts lays a strong foundation for tackling more complex geometrical problems. In the following sections we will delve deeper into these concepts, exploring different shapes and their formulas, and understanding their significance in real-life scenarios. So let's embark on this geometrical journey and unravel the mysteries of surface area and volume together. Let's start our exploration with surface area. Imagine painting a box. The area you cover with paint represents the box's surface area. Now, different shapes have different formulas for calculating surface area, owing to their unique structures. A cube, for instance, has 6 equal square faces, so its surface area is 6 times the area of one face. Mathematically, it can be expressed as 6a squared, where a is the length of one side of the cube. Moving on to a sphere, think of a ball. It has a curved surface, unlike the flat faces of a cube. The surface area of a sphere is calculated using the formula 4πr squared, where r is the radius of the sphere. A cylinder, like a can, has 2 circular bases and a curved surface. Its surface area is calculated by adding the areas of the 2 bases and the curved surface. The formula is 2πr times the sum of r and h, where r is the radius of the base and h is the height of the cylinder. Remember, these formulas are tools to help us calculate surface area. Understanding the reasoning behind them is crucial. Now let's dive into the concept of volume. Imagine a water tank. The amount of water it can hold represents its volume. Like surface area, the formula for calculating volume varies depending on the shape. For a cube, volume is the product of its length, width, and height. Since all sides of a cube are equal, the formula is a cubed, where a is the length of one side. In the case of a sphere, the volume is calculated using the formula 4/3 πr cubed, where r is the radius of the sphere. For a cylinder, the volume is the product of the base area and the height. The formula is πr squared h, where r is the radius of the base and h is the height of the cylinder. These formulas might seem daunting at first, but with practice they become second nature. Surface area and volume are not just abstract mathematical concepts, they have numerous real-world applications. Let's explore a few examples. Imagine painting your room. Knowing the surface area of the walls helps you determine the amount of paint required. Similarly, when designing a water tank, understanding volume ensures it holds the desired amount of water. In manufacturing, calculating the surface area of materials helps optimize production and minimize waste. For instance, in packaging, knowing the surface area of a box allows manufacturers to use the minimum amount of cardboard, reducing costs and environmental impact. These examples highlight the practical significance of surface area and volume in various fields, from construction to engineering and beyond. Section 5. The cube, a six-sided wonder. The cube, with its 6 square faces, is one of the most fundamental three-dimensional shapes. Its symmetry and simplicity make it a great starting point for understanding surface area and volume. Imagine a cube-shaped box with each side measuring 5 centimeters. To calculate its surface area, we use the formula 6a squared, where a is the length of one side. Substituting a with 5 centimeters, we get surface area equals 6 times 5 centimeters squared, which equals 150 square centimeters. This means you would need 150 square centimeters of wrapping paper to completely cover the box. Now, let's calculate the volume of this cube. Using the formula a cubed, we get volume equals 5 centimeters cubed, which equals 125 cubic centimeters. This means the box can hold 125 cubic centimeters of water or any other substance. Section 6. Unraveling the cylinder from cans to pipes. Cylinders are everywhere. From cans to pipes, their practical applications are numerous. Understanding how to calculate their surface area and volume is crucial in various fields. Consider a cylindrical can with a radius of 7 centimeters and a height of 10 centimeters. To calculate its surface area, we use the formula 2 PER times the sum of r and h, where r is the radius and h is the height. Substituting the values, we get surface area equals 2 times pi times 7 centimeters times the sum of 7 centimeters and 10 centimeters, which is approximately 961.63 square centimeters. This means you would need approximately 961.63 square centimeters of material to make this can. Now let's calculate its volume using the formula PER squared h. Volume equals pi times 7 centimeters squared times 10 centimeters, which is approximately 1,539.38 cubic centimeters. This means the can can hold approximately 1,539.38 cubic centimeters of liquid or any other substance. Section 7. Decoding the sphere. Planets, balls, and more. Spheres with their perfectly curved surfaces are fascinating shapes found everywhere in nature and man-made objects. From planets to balls, their unique geometry requires specific formulas for calculating surface area and volume. Imagine a basketball with a radius of 12 centimeters. To calculate its surface area, we use the formula 4 PIR squared, where r is the radius. Substituting the value, we get surface area equals 4 times pi times 12 centimeters squared, which is approximately 1,809.56 square centimeters. This means you would need approximately 1,809.56 square centimeters of leather or synthetic material to make this basketball. Now, let's calculate its volume using the formula 4/3 PIR cubed. Volume equals 4/3 times pi times 12 centimeters cubed, which is approximately 7,238.23 cubic centimeters. This means the basketball can hold approximately 7,238.23 cubic centimeters of air or any other substance. Understanding these formulas allows us to appreciate the vastness of planets and the capacity of everyday objects like balls. Section 8. Surface area and volume importance and applications. The concepts of surface area and volume extend far beyond textbook exercises. They play a crucial role in various fields, impacting our daily lives in countless ways. In architecture and construction, these concepts are fundamental for designing buildings, bridges, and other structures. Architects and engineers use surface area calculations to determine material requirements, optimize structural integrity, and ensure efficient use of space. Volume calculations are essential for determining the capacity of rooms, tanks, and other containers. In manufacturing, understanding surface area and volume is crucial for optimizing production processes, minimizing waste, and reducing costs. For example, in packaging, knowing the surface area of a product helps determine the minimum amount of material needed, while volume calculations ensure the package can accommodate the product effectively. These examples highlight the practical significance of surface area and volume in various fields, demonstrating their real-world applications and impact on our lives. Section 9. Conclusion. Mastering the concepts. As we conclude our exploration of surface area and volume, it's important to remember that these concepts are not merely mathematical formulas to be memorized. They are fundamental principles that govern the physical world around us. From the design of buildings to the packaging of products, surface area and volume play a crucial role in countless aspects of our lives. By understanding these concepts, we gain a deeper appreciation for the world's intricate workings and develop essential problem-solving skills applicable to various fields. So, continue to explore, question, and apply these concepts in your daily lives. The more you engage with them, the more intuitive and relevant they become. Remember, mastering surface area and volume is not just about acing exams, it's about comprehending the world around us and unlocking its countless possibilities.